So in this problem, guys, basically all we're going to do is go ahead and we're given a problem or we're given information. I like to sketch the angle. Now, when you guys remember those notes, I gave you guys two different types of angles, right? Two different oblique triangles, right? It really doesn't matter which triangle you graph. I would just recommend just plotting a triangle and then entering in the information. I always kind of graph this one just by habit. But if you guys want to graph, or create another triangle, that's perfectly fine. But I always just like create this one by habit, and then I adjust it based on what the sides are. So angle A is 50 degrees. Angle B is 62 degrees. And side length A is 4. Does everybody see how I did that? Now, all I'm simply doing is going back to looking at my law of sines. And I realize that when you're doing the law of sines, remember, you have to have either angle, angle, side, or side, side, angle. This is an example of angle, angle, side. So therefore, do I have an ambiguous case? No. Ambiguous case is only for side, side, angle, right? So it's only angle, angle, side. So I can just do the law of sines and not have to worry about the ambiguous case, which once we do the next problem, you'll realize that's really a good feeling. So to go ahead and complete this problem, you realize that do we have any values for C, sine of C, or sorry, angle C or side C? No. So guess what? That ratio of C over sine of C, we're just not going to worry about it. We don't need it. We only need a ratio equal to another ratio to have a proportion to solve. So basically, I'm just going to use sine of A. Sorry. We did A over sine of A. Doesn't really matter how it is. Equals B over sine of B. Now, I'm just going to enter in the information I know. A, actually, we do. I should have figured that out, but that's OK. A over sine of A is 4 over the sine of 50 degrees is equal to B over the sine of 62. Yes? Now, obviously, ladies and gentlemen, to solve for B, you could apply cross multiplication. In reality, you really just need to get rid of the sine of 62 on the denominator. So therefore, you'd see that B, when you multiply out and simplify, you get 4 times the sine of 62 degrees divided by 50. So therefore, I'll take Aaron's calculator back again. Is everybody OK with how I got this solved? Does everybody see what I did? I'm just not showing my steps like I told you I wasn't going to do at the beginning of class. But is everybody OK with how I did that? I just multiplied a sine of 62 on both sides. So now, again, make sure your calculator is in degree mode. And all you're going to do is do 4 times the sine of 62. And then divide that by, that's the sine of 50. Why did I not write that in there? Divided by the sine of 50 degrees. And that's going to be 4.61 approximately. Well, unless you are otherwise told to do so, or if you have a significant digit, I always just round it to the hundredths. So I'm going to do B is approximately 4.61. OK? So now I know what B is. B is going to be 4.61. All right, so now we need to figure out C. Now, we weren't given any information on C. However, we do have some other information that we can use to help us find C. Ladies and gentlemen, if we have 2 angles of a triangle, can we figure out the third angle? Yeah, because all the angles of a triangle add up to 180. So therefore, to find C, I can simply write this equation. 180 minus 50 degrees minus 60 degrees. Right? 68. Yep. So therefore, C equals 68 degrees. So now I know 68 degrees. Now, can I use a relationship to solve for C? Yeah. Of course you can. So again, I'll do this. However, to determine which ratio I want to use, since I was given the ratio of A, I would prefer that you guys use this ratio just in case you did something wrong and solve for B. So I'm going to use a ratio for A. So therefore, I'll just rewrite that ratio. And that's going to equal C over the sine of 68 degrees. Are you guys OK with me not writing A over sine of A is equal to C over sine of C? I just plugged all the information in. OK? And then C is equal to, again, solve it, which would be 4 times the sine of 68 degrees all over the sine of 50 degrees. So then, again, I need to go back to my calculator. No! And do 4 times the sine of 68, and then divided by the sine of 50. And I get 4.84. And therefore, this is 4.84. OK. So now we go ahead and look at our triangle, and we say, does this triangle look like it makes sense? Does the largest side length have the largest opposing side? Yes? So all the side lengths, and they're all roughly around, right? There's not a side that's like 400 or 1,000 or something. They're all, looks like it works, right? So I check, make sure everything works, and there we go. That's it. So we're not using any other thing besides the law of sines for this problem. OK?